welcome back to the YouTube channel. So again, my name is Rica Casabuena from ECE31, and for today's episode of our Internet of Things laboratory, we will be having our experiment number 4, okay, that will allow us to explore our smart homes, okay, explore the smart home of our packet tracer. So now we'll be starting with our experiment by changing the username here on the guest. And then let's have the pop-up here, the instruction, then let's select doc. So for this experiment, for our packet tracer, we will be exploring the smart home. So one of our objective is to, basically to explore the smart home, and second is to analyze the usage of fog computing in the smart home. So for our background or scenario, in this activity, you will explore the smart home example. So depending on the application, some data is best processed close to the source. The smart home example takes advantage of fog computing to monitor and act upon the levels of smoke detected in the home. So for our part 1, exploring our smart home, and for our step 1, we will be understanding the devices that comprise the smart home. So commonly, ISPs deliver data and video over a single coaxial cable. Starting from the attic, so where's our attic? So basically here on the top, near the roof, a coaxial splitter is used to separate the video signal from the data signal. So this is our coaxial splitter here. So for our question A, 2 coaxial cables leave the coaxial splitter in the topology shown. Which devices does the coaxial cable connect to? So the devices connected to our coaxial, connected to our coaxial cable, which is connected to our coaxial splitter, is the cable modem here. Okay, as you can see, it's connected to the coaxial splitter here, and then the TV here. So those are the devices connected to our coaxial splitter. So which is connected to our coaxial cable. So for letter B, the cable modem is the interface between the ISP's network and the home's network. To which devices does the cable modem connect to? So our cable modem here is connected to our home gateway here. Okay, so for our notes, the home gateway acts as a concentrator and the router to all internal home devices. It also provides a web-based interface that allows users to monitor and control various smart home devices. Notice that the home devices can connect to the home gateway through either a wireless or a wired connection. So for our note, Packet Tracer uses dash beams to represent wireless connections, but it can make it hard to read when too many devices are present. To turn it on, we should go to the options. Okay, click Preferences. Okay, then we should go to the hide tab here, and then we should uncheck. Okay, we should uncheck hide wireless. Okay, hide wireless dash cellular connection. So we should go back here. Then, as you can see, a dotted line, or let's say a dash beams, has been shown on the screen from the home gateway. So this shows all of the home devices connected to our home gateway, which is being asked in question letter C. So as we can see, the dash beams represent the connection of the devices to our home gateway. So the devices connected to the home gateway are the smart window, the garage door. Wow, interesting. And then we also have here the smart lamp. It's also connected to our home gateway here. So let's put it here. Our smart water meter is also connected to the home gateway. Our smart sprinkler, basically all of the home appliances which involves smart system. So we also have here the smart alarm, of course. We also have here our tablet. So what else? We also have here our smart coffee maker. Wow. We also have here our temperature meter, our smoke. No. Yep. Our smart door here, and what else? Yep, temperature. And then we also have here our smoke detector. Okay, and the tablet is connected to the internet. Our smartphone is also connected to the home gateway as well as to the internet. Yep, so those are all Actually, our smart fan is also connected to our home gateway. So those are all of the devices connected to our home gateway. So for our step 2, interacting with the smart home, the devices in the smart home can be monitored and controlled remotely through any computer in the home. Because all smart devices connect to the home gateway, which hosts a web-based interface, tablets, smartphones, laptops, or desktop computers can be used to interact with the smart devices. So for our instruction, we will be clicking the tablet. So the tablet is located on the bed in the master's bedroom. So let's click the tablet and then let's go back to our instructions here. And then we should navigate desktop and then we should go to our web browser here. Okay, then we'll be in the address bar, type in 192. So 192 dot 192.168.25.1. So after that, we'll be clicking go. This is the IP address of the home gateway. Then we'll be logging in using admin as our username and then admin as our password as well. Okay, let's submit. So as you can see, we can monitor our smart home devices and appliances under our desktop. Okay, desktop, which is under our web browser using our tablets, because as you can remember, we access this using our tablet, which is shown here. So here on the list, you can see the devices or the appliances in our smart home that can be controlled. So we have here the smoke detector, smart alarm, garage door, smart window, smart door, smart sprinkler, smart water meter, temperature meter, smart coffee maker, smart fan, and smart lamp. And if you can still remember, these are some of the devices that are connected, okay, that are connected in the home gateway. So since home gateway is connected as well to our tablet, these appliances can be controlled using our tablet. So as you can see, okay, the smart door is currently unlocked. So let's check. Yep. So our smart door is currently unlocked, represented by a green light on its doorknob. So as you can see here, it is unlocked, so meaning it's open. But it can be locked remotely. So we can use, let's say, a remote using our tablet or using our cell phones or devices to remotely lock our doors. So this is very helpful when we are outside and we want to make sure that our house is safe. So we should click the smart door in the browser to expand the option. So let's find, no, that's smart window. So as you can see here, the smart door is unlocked, so we can click lock to the door. So let's check. As you can see, the smart door was locked and um, the light became red, meaning it was locked already. So no thief or let's say no person can go inside the house without any permission from us. So was the door locked? How do you know? Yep, the door was already locked remotely with the red indicator here, the red LED indicator. So click unlock to unlock the door. So let's unlock the door. So as you can see, the the LED here became green. So click the smoke detector in the browser. So in the browser to expand the section. Let's click this one. What is the smoke level reading provided by the smoke detector? So we should click on the smoke detector in the browser to expand the section. So what is the smoke level reading provided by the smoke detector? So our answer is 0. So the level here is 0. Can the smoke detector be controlled? No. So smart devices can also be controlled directly, representing physical interaction. So within the logical work area of packet tracer, hold down the Alt key and click the smart coffee maker to turn it on or off. So within the logical work area of packet tracer, so where's our smart coffee here? Let's go back. So we can hold down the Alt key and click the smart coffee maker to turn it on or off. So let's click Alt key. Okay, we can by clicking the Alt key here and by pointing on our smart coffee maker, we can wait. Let me adjust. So focus on the coffee maker. We can turn on and off our coffee maker here using our Alt button here and by clicking the coffee maker. So for our part 2, fog computing and the smart home. So the MCU added to the smart home is used to monitor the smoke levels, read by the smoke sensor, and decide if the house should be ventilated. If the carbon monoxide levels freezes above 10.3 units, the MCU is programmed to automatically open the window, front door, garage door, and start the fan in high speed. This action is only reverted, close doors and windows, stop the fan, when the carbon monoxide levels drop below 1 unit. So for our step 1, we should run the classic car. So the owner keeps a classic car in the garage and needs to be run occasionally. The classic car generates carbon monoxide, which raises the levels within the premises. So we should click the tablet located on the bed in the master's bedroom. Okay, let's have the instructions here, and then navigate to desktop. Okay, so let's uh, exit here, then web browser. So again, we'll be typing 192.168.25.1. Okay, wait a moment. So dot, that's dot, and that's dot, and this one is dot. And this is the IP address of the home gateway. So we'll be logging in again with admin as our username. Password should be admin. Then let's click submit. Okay, and click on the smoke detector within the smart home. Leave this window visible so you can monitor the smoke level. So we'll be leaving this to monitor it. Start the car engine by holding the Alt key and clicking the classic car. So let's check here the car. Oh, wait a moment. This one. So wait a moment. Let's have our pop-up here. So we'll be starting the car. As you can see, there is smoke emission from the car. So that is an indication that it is working. So as you can see, our smoke detector here, okay, the level changes from 0 to 1.637. So let's have our instruction here. So what happens to the air inside the house with the car running inside the garage? So wait a moment. So yep, as you can see, just like what I told you a while ago, our smoke level here, okay, our smoke detector already detected smoke in the house, raising the level of the smoke from 0 to 1.637. And as you can see here, the temperature, okay, look at here, the temperature increases significantly as well. From 0 to, a while ago, it became 3 degrees Celsius. Let's turn on again. Turn off, then turn on again. Okay, as you can see here, okay, as you can see, the smoke detector level raises continuously. Okay, from 1 to 10 a while ago. So let's turn off again. So let's turn on. Yep. Okay, as you can see, the smoke detector level increases significantly when we let the car engine works. So it increases up until 10.52, which is the highest level so far. So answering the question, what happens to the air inside the house after the MCU? This MCU here, which is our board, opens the door and window and start the fan. So if you can notice, our smart door here automatically open when we start the engine of the car. Then let's look for our window. And our window here, as you can see. Okay, let's put it here. So our window automatically open as well when the engine of the car started. So this is an indication that the level of smoke inside the house is increasing. Thus, the smart home is automatically adapting to mitigate or control the smoke level inside the house. So, does the MCU close the doors and window and stop the fan? So, yep, let's check for the fan here. Yep, so the temperature increases as well. Okay, the temperature increases when the engine started. So, let's stop the car. Let's turn on. So, wait. Okay, so let's go back to our instruction here. Does the MCU close the doors and window and stop the fan? Yup. As you can see, the door automatically opens, the smart window automatically opens, and the smart fan automatically turn on as well. So let's stop the car. Let's stop the engine of the car. Okay, yep. So as you can see, it's so awesome. The window, the smart door, as well as the fan automatically turns off when the engine of the car has been stopped. So that's the role of our MCU and our smart home, to automatically control the appliances without our supervision. So we can do that remotely when we're outside of the house. So while still monitoring the levels, stop the classic car's engine by holding Alt key and click the classic car. What happens to air quality inside the house after the engine is stopped? So let's check the air quality inside the house. Okay, when the engine stops, our smoke detector level decreases to zero. It goes back to zero, meaning the smoke levels inside the house is controllable already. Probably it became zero already. So if the smoke level decreases significantly, then we don't have to open the window and open the smart door automatically. So this allows us to protect the house from possible fire because of the amount of carbon monoxide inside the house, and then automatically closing the door and the window allows us to protect the house from thieves when we're outside of the house. So let's go back to our question here. What happens to the doors, window, and fan? Yep, just like what I've said, it automatically closed when the car's engine has been shut down or has been off. So for our part three reflection, this example shows that the decision between cloud and fog processing depends on the application. In the smart home example, fog computing was the best option. In the smart home example, the data generated by the smoke sensors were processed and used to make decisions regarding the house air quality. So this is really a significant innovation, especially for automation, for house automation, which is in demand nowadays because of the rising technology that we have. So in this scenario, there was no need to send out sensor data to the cloud for processing. Cloud processing would slow down the response time, potentially putting lives in danger. Wow. So you don't have to, time will not be wasted because the information going, will not be going to the cloud anymore, will not be processed by the cloud anymore, but instead it is directly relied to the appliances, to the smart home devices, which decreases the time, which decreases the transmission of information, which makes the smart home more efficient. That's really awesome. And then another possible problem relates to the internet link. If the connection to the internet was lost, the entire system would fail, putting lives at risk. So, yeah, one cons for this smart home application is that we need an internet connection. Yep. So basically, when you're running a home automation, you'll probably need an internet to remotely control the devices. So that's one of the factors that we should consider in running our smart home appliances and devices. So that's our experiment number 4, which is exploring the smart home under our data communications laboratory experiment. So again, my name is Rica Casabuena from Exp4, and I hope you learned a lot from our experiment today. So see you on our next laboratories. Bye for now.